Right, so here we go. So just let me check one thing and then you can start. All right, so so basically what you guys need to understand is that there's something called momentum. Momentum is basically the product of mass and velocity. So when you basically talk about momentum, the symbol that we use for momentum is P, and the formula is momentum is mass times velocity. The SI units, you could write Newton second or kg, meters per second, they're the same thing. And then it's basically a vector quantity. So we really need to take care of its direction, okay? Now one of the things that they're going to ask you a lot is the change in momentum. So the change in momentum is like, let's suppose you have an object that's going with the initial velocity u, and then you apply a force on it for a certain period of time. So after that it will change its velocity. Alright, please draw this. I'm just coming 1 minute. So then this basically we can say that the initial momentum was, suppose the mass of this object is m, so it was mu, and the final momentum is basically mv. So then the change in momentum in physics, the change is written as delta p. We write as mv minus mu, which means final minus initial momentum. So that would bring a change in momentum. Now, I just want to basically give you a heads up with this example that we're going to do right now. In fact, you guys are going to do it, and then let's talk about it and understand why this is very important. So suppose there is a wall just there, and there's an object with mass m that's going with the velocity u, and then it hits the wall and then rebounds with the same velocity u. So it just says, say a molecule of mass m hits a wall and rebounds at the same velocity u. So they say find the expression of change of momentum. Can you guys do it? Please try. Makes sense.
Sir, is the speed the same before and after it's reflected?
Yes, the speed is same. That's the point,
So then is it 0?
It is 0. Okay. All right. What do you think, Ariba? Is it 0? And Varisha? No idea. Please don't say this. There has to be some answer. Okay. So.
Isn't the momentum?
Momentum what?
Isn't it twice in chain?
It will be. You're saying it will be 2 times mu?
Something like that, yeah.
Okay. Well, she's correct. Now, let me tell you, Safir, something, and Ariba. So, the momentum initial is, if you take this as mu, right? You take this as negative, this side is positive, so it will be negative, because this is a vector quantity, And then, if you take final momentum to be mu, when you take the change in momentum, how do you take the change? Final momentum minus initial, right? So final would be mu minus, and initial was minus mu. So it's going to give you 2 mu. Do you understand?
Yeah, sir. I understand the mistake.
Yeah, so basically always treat it as a, as a vector quantity, never ever as a scalar, right? Now, so if I tend to, if they say, okay, make a graph of what you've done here, so basically we can simply make a graph, and we can say, okay, if we look at this example over the top, oh no, so we can say, okay, so this, the molecule was traveling at momentum, so it's momentum, it's time, so for some time it was traveling at minus mu, and then it switched like the direction when it hit, and the direction was switched because of the force that was applied on it, which means that now it has gone to positive mu. So you can make a graph, right? Now we're going to come back to this section, okay, in a bit, and understand what basically this section means. But before that, we need to understand witnessed is basically impulse. Impulse basically is defined as the product of force and momentum. Sorry, my bad. Time for which this force was applied. Alright, which causes a change in momentum. Okay, so impulse is basically force times time, and it causes the change in momentum, as we know. Now if I just expand the other side, this will be mv minus mu, so that's the change in momentum. And if I divide the time there, so force will be mv minus mu divided by t. And then if I take, this is basically the real definition of force, right? And here we're gonna write Newton's second law, because Newton's second law really defines the force, and it says that resultant force is the rate of change of momentum. So basically, this resultant force, Newton claimed that it is change in momentum, and the expanded version we just saw that it was mv minus mu over t. And then if I take mass common, so it will be v minus u over t. Can somebody please tell me what is this v minus u over t? Have you ever read it, seen it before? You guys have never seen this formula before. How is that even possible?
Acceleration.
Yes. So acceleration, Ariba, are you there? So it will be mass times acceleration, and that's what the Newton's second law was all about, right? Now, interestingly, the second law came first, and then the first law followed, because he needed to explain this, and the best way to explain this was through Newton's first law. So then we were just going to write Newton's first law. Which basically states that an object will continue to move at constant speed in a straight line unless or stay at rest unless an external force acts. Basically, he's talking about that resultant force that we have just seen in the second law. Now, which basically means that if we go back to what we saw earlier happening to the object that changed direction, right? So you guys need to understand that here, this is basically the time of contact with the wall, and then suppose we call this as t. So during this time, a change in momentum is happening. So if we find the change in momentum, that is going to be 2mu that we found earlier, happened for a time. So if we take the gradient of this graph or that line, so the gradient of this line is basically change in momentum over the time. So that's going to be the force. So this means that finding the gradient of this line would give us the force that was applied by the wall on the ball. Is it clear, everybody? Any questions now? Okay. Now, so going with this one, we just understood what Newton's second law and the first law is, and we also understood how we can interpret the graph of momentum in time. So the gradient would always show you the resultant force. So now we would basically, I just want to give you a small note, and that's very important to write, that the direction of acceleration is always the same as direction of resultant force. So you guys need to remember this. The reason is that velocity might have a different direction, like we just said. So you will always accelerate in the direction resultant force. That's how you can move in circles. You can, go in a straight line or slow down or speed up, and that's how it works. All right. So you guys need to remember that. Now, keeping that in mind, then we just need to basically learn some of the rules, say some of the diagrams which Newton's second law and the first law follow. So let's look at that. So first of all, we are going to learn about the forces on an inclined plane. Okay. Just a second, please. Okay. So, with inclined planes, so first thing you guys need to remember is that suppose you got a plane like this, and then that's the vertical reference, and this looks like this. Okay. Now there's an object. It's basically right here. So, and this is the angle at which the inclined plane is. Okay. Whenever you're going to look at an inclined question, just remember that you just need to draw the weight first, and the weight is always downwards, like this. Once you've drawn the weight, it's vertically down. You will then make one component perpendicular to the slope. Perpendicular means that it's 90 degrees. And then one component always down the slope. Usually call this as weights component, weight component that is perpendicular, and this is the weights component that's down the slope. Alright, now then the next thing you guys need to know is that this angle, that is the angle between the slope and the horizontal line, is the same angle as this angle that is between the weight and the component of weight that is perpendicular to the slope. Alright, is it clear, everybody? Which then makes this component perpendicular as W cos of theta, and the other one as W sine of theta. Okay, any questions here? Please let me know. All right, now so let's try and do an example that will help us understand about the inclined planes. Suppose they have given you shown an object and this is 30 degrees, and they say, okay, object of weight 20 newtons rests on an inclined plane. Says the friction force is 4 newtons which acts up the slope. Okay. Now what they want is, they want you people to find the resultant force. Then they want you to find the acceleration of object, and finally they would like you to find the reaction force on the object by the slope. Alright, now let's try to do this. The very first thing you guys need to understand is that this object weight is going to go like act downwards, and the value of weight is 20 newtons. Then you got to make one vector that is perpendicular and one vector that is down the slope, and this angle is 30 degrees as I told you earlier. Is it clear, Safir? Hariba?
Yes, sir.
Okay, Varisha, is it clear?
Yes, sir.
Okay. Now, this would mean that this force will be W cos of 30, its adjacent component, and this is W sine of 30. And the friction force is acting upwards. Let's call this F, right? And there is also a reaction, and reaction force is always perpendicular to the slope, so let's call this R. Okay, now first of all I would like to tell you that when you look at this axis, okay, this line perpendicular to slope, so there are only two forces, and because it's not neither this like going down in the same line or up, which means that we should remember that R is equal to the W cos theta, and then we can also resolve all the forces on the slope like this. Okay, so we're going to look at this because the resultant force would only be here in the parallel line to the slope. Okay, so now we can write that the resultant force can be found out. Let me change the color a bit. So resultant force will be equal to W sine 30 minus 4. So W is 20, sine 30 minus 4. And when you try to solve this should give you 6 newtons. Alright. Now what you're going to do is that we have to find the acceleration. Now to find the acceleration, the only thing we can do is use F equals to ma. The force is 6 newtons. Now to find the mass, we already know that W is equal to mg. To find the mass, we need to divide the weight by g. The weight was 20 divided by 9.81, and we want to find the acceleration. So the acceleration would be about 2.9 meters per second square. Is it clear, everyone? All right. Now the thing is that they say, okay, find the reaction force on the object by the slope. So the reaction force that I see is R, and there's no other force other than W cos theta. So it means this R is equal to W cos of 30. So we got to find this R. This is 20 cos 30, and that's going to be 17.3 newtons. All right, please look at it and let me know if you do not understand something.
Sir, how did you find the acceleration?
I used F equals to ma, right? I put the resultant force, which I found in the previous part, as F. Now for the mass, I don't know the mass, but I know the weight, because weight is mass times acceleration due to gravity. So I divided weight with 9.81 and then put it there. Do you understand? Yes, Farisha. Is it clear or no?
Yes, sir.
I think your voice was breaking. I couldn't understand. Come again, please.
Yes, sir. Yes.
Okay,
I understood.
okay. So that's how then you can find the reaction force. All right. Just give me 1 second, please. Usually the slope questions, they come in MCQs, okay, but and they're very, like, not many come, so it's not like you'll always find them, but they are there, so we just need to be aware of that. Just after that, I just want to show you one of the exam questions actually, so just give me a second till I post it. Excuse me. Hello. जी वालेकुम सलाम. नहीं, मैं actually I'm teaching myself right now. Can I sir call you back in half an hour? Okay sir. All right sir. Okay, so basically where are you people? Wait, I'm putting this question. Interesting. Okay, I think it is going to take time, but I just wanted to show you. Um, the questions are like super easy. Um, just came in. It's just loading the screen right now. Can do it. Okay, never mind. We can look at it later. So the next thing you guys need to basically understand is the. Okay, it worked. So great. Wait a second. Then. Ariba, are you there? Why can't I hear you? Ariba? Okay, it will show up in a bit.
Sir, can you hear me?
Yes, now I can hear you. I've been calling you Ariba so many times.
I'm sorry, sir. I didn't know what happened.
Okay. Alright, so now, um, where were we? Okay, fine. So, oh, please appear. Anyway, so this is a question from 2012. It came, so you just need to remember that it says the diagram shows an object on an inclined surface. The component of weight parallel to the surface is this. So you already know that basically um, there will be a component down the slope. There will be like this. This is angle theta, so this is going to be W sine theta. So this is the answer then. All right. Now, okay. So then you guys need to go to the next thing. The next thing are I'm going to discuss few cases. So let's hope we can try. We can discuss case 1 first. Okay. Now, when the meeting ends, please, I want you guys to rejoin the same link. Okay, it's going to end in about 2 minutes or 3 minutes. Okay, anyway, so then we need to look at when two bodies are connected with an inextensible string. So suppose you got an object like this, they're like two cards, car and a cart. So this one is like 4 kilograms, this one is like 2 kilograms. So they're basically accelerating this way, and let's call this M1, let's call this M2. There's a force on them as 100 newtons, and we gotta see this. Okay, now whenever two bodies that you see, whether it's passing over a pulley or they're just attached with another with a string or anything, the step one to always solve these questions are that you find the acceleration of whole system. So to find the acceleration of the whole system, you need to use F equals to ma. Now the only force here I see is 100, and then the mass, you got to add them together and then find the acceleration. So if you find it, the acceleration is going to be 16.7 meters per second square. Alright, it means that basically this whole system is going at this acceleration and it will accelerate together. Okay, now in the next, so basically suppose they want us to find the tension. So this M1 is pulling it with T1 and this is pulling it with T2. So we want to then do the step 2, and then what you're going to do is that exclude the first body and apply F equals to ma. Now, so if I exclude this whole system, like from this center, so if I just exclude the first body, okay, so wait a second, we for this 2 minutes and then we starting. So okay, so what you're gonna do then is when you exclude the body from here, you can just make the first body. That's M1, and then just see that it only has one force here, T1, but of course the acceleration of the whole system is the same, so it will be 16.7 meters per second square. And then the mass is 2 kg. Now just separately apply F equals to ma, and this will be T1, the mass is 2, and the acceleration is 16.7, so you should end up getting something like 33 newtons, right? Is it clear? Now I just want to ask you people that do you think T1 and T2 will be different or the same? Marisha, Safir, what do you say? T1 or T2 will be different or the same?
Different.
Different, okay. Marisha, you agree to this?
Yes.
Okay, let's check it out. So now step 3, you're going to basically apply F equals to ma on the other body. So for the other body, if you just look at it, like there is 100 Newton on this side and there is T2 on this side, and then the acceleration is the same as 16.7 meters per second square and 4 kg and m2. Okay, so then what you're going to do is you're going to apply F equals to ma, and then to find the resultant force you're going to do 100 minus T2 equals to 4 kg times 16.7 meters per second square. Okay, if you try to find this, basically T2 will also be 33 newtons. It would be the same, not different. Now I tell you why you guys were wrong in the first place. Because if M1 pulls M2 with a certain force, then M2 will pull M1 with the same force, and this is what basically indicates that T1 is equal to T2 because of Newton's third law. So the action you do on an object, the object will do the same in the opposite direction. All right, do you guys understand this? Right, now I'm gonna give you guys a little bit of work for as a homework. Now I just want you guys to work on it, and when we meet the next time we're going to discuss this. Okay, so it's basically the same way that I have taught you. Everything will be the same. You just need to apply the same rules. Okay, so what this says that this is cable 1, cable 2, cable 3, and there's a 8000 Newton force here, 900 here, 800 here, and 700 and 600. And they say M is equal to 500 kg. This is 2M, this is 4M, this is 5M, and this is 14M. And they say you just need to find basically each force, the force in each cable. Okay, T3. So they say, okay, find T1, T2, and T3. Is it clear, everybody? Any questions? Okay, so Safir and Marisha, please try to do this work, and then when we see each other in the next week, we'll continue from here. Also, Safir, you were there in the previous class, right? Or Burhan was, I don't remember.
Sir, Burhan was not there.
Okay, so Safir, please tell him too that you need to complete the projectiles homework, right?
Okay, sir.
Alright, so I'll see you guys in the next week. Have a nice day. Bye.